We're going to speak about renormalization, and we're going to see how it's most certainly indicative of what is occurring within the recursive mechanism of the relativity of two mirrors. In fact, I speak a lot about these nuances or these entropic changes that occur within recursion throughout my Facebook theorem page, but I'm going to kind of abbreviate it here in this video. If two recursive matrices, errors of time we've discussed in former videos, if two recursive matrices emerge due to the relativity of the two sides of a reflected string we've described as two mirrors facing each other, then all information on the surface of the planes, as well as the information recursively represented into the matrices, are entangled. So that means that not only will the surfaces move relative to each other, if indeed the black holes can actually come closer or farther from each other, but all information represented as individual membranes of recursion, all membranes move relative to all other membranes. Not to mention that all motions or movements on this side between the membranes in the whole infinite space is exactly the opposite and is balanced on this side. So we can define the recursive matrix as the infinite propagation of not only the information dwelling on the surfaces, but as well the real distance between the two sides of the string, and that's represented in the phase space. So the phase space propagates the distance that the real object is from the surface down to infinity. The membranes themselves copy two things, not just the information that's lighting up on the surface, but recursion also copies infinitely the actual dimensions of the mirror itself, or the surface of a black hole. So the recursion represents an infinite propagation of not only the information dwelling on the surface, but as well the real distance between the sides of the string. In order to make these points with more clarity and lucidity, I will once again refer to the model itself and as literally depicting these relationships and processes. These processes that I'm speaking on can literally be observed and measured, and it encompasses many inherent mathematical qualities, the implications mathematically of the system that we're describing, and with all of its mathematical implications and principal nuances, can be observed quite literally. So what I'm going to do first is see if we can come to understand or define what is renormalization, and then we're going to see how it's described or depicted by my model, the recursion scenario. And the question could be, can we observe and measure this renormalization phenomenon by referring to the mirror-to-mirror model? So the recursion of information in the matrices respectively, side A mirror, side B mirror, virtually represents that the information symmetry, volume of light ring that's on the surface existing on the topology of the mirrors, is being further extended into a supersymmetric matrix. So all membranes of recursion, and when we use the word membranes, we could actually replace the M in M theory with membrane theory. Of course, it's up in the air from the theoretical physics standpoint of what that M really represents. I believe this model, the mirror-to-mirror model, will help us to fully understand what that M represents. But at this point, I'm going to refer to the membranes of recursion as actually embodying the principles and the insights that's coming out of M theory or lattice theory, but both technically are Lie algebraic constructs. So all these membranes in the virtual interior of the mirrors represent individual symmetric copies, self-similar and self-replicating, from the surface. So this in essence is a recursive space-time continuum or arrow of time. So these virtual individual symmetric copies of the information of the symmetry on the surface is further stretched or extended into the matrix, the lattice. So if a real object is reflecting between two mirrors, then the reflected information on the surfaces of the mirrors will encompass a certain volume of the space area or dimensions of the mirror itself. In other words, if we have a mirror that's a foot by foot, we can say if the object is so close to that mirror that only a small volume of the surface area of that mirror actually represents information. The rest of it just represents the plane itself, or the infield. And again, we're considering this, I'm equating this to dark matter. The mirror is the dark matter. Whether or not it is lit up with information is a potential, and that's based on the uncertainty principle. So not only is the information on the surface communicated into the matrix, but as well the dimensions of the plane are communicated into the virtual space. Now again, we're considering a flat mirror here, a plane, versus we'll get into the spherical aspects of it in later videos. But for right now, if you have two mirrors facing each other and a real object in between, and let's say the room is dark, the room that these mirrors are in is completely dark, and you have a lit up object that's sitting in between these two mirrors. That object, that light object, is communicated to each membrane. But the membranes don't necessarily fully embody just the information. The membranes are actually also copying the surface area of the surface to each membrane. So each membrane is copying not only the planes or the surface area, but it's also copying the information of the surface area. And I'm showing the distinction between the dark matter medium, the mirror, and the black hole information. They're separate, but you cannot have the black hole form or the black hole information if the dark matter plane is not there for it to be implanted upon. So it's communicated through the matrix, that is the information, but as well the dimensions of the plane are communicated to each stage of recursion. And of course, remember that the only difference is that the relationship between the fluid open space, or the distance between mirrors, as relative to both manifolds, is a real reflected body of information. All things that are beyond that, which represent recursion, are virtual copies. So we have to note that the information on the surface is not the same as the surface. In other words, the reflected ball reflected to the surface of the mirror is not the same as the mirror itself. So here's what represents the membranes that exist in the virtual interior of the mirror. The recursive membranes are merely the dimensions of the entire mirror surface as communicated into the matrix, and of course with each copy of that mirror surface volume of area. Also accompanying that on each membrane is a contracted version of the symmetry of the information of the light ring on the surface. So these recursive copies of the surface area of the plane are not the same as the information on each membrane. That's also communicated on each slice or layer inside the matrix. So along with the membranes and information as recursively represented, there's always the accompanying phase space that also exists within the matrix and as separating all membranes from all other membranes. This phase space serves to separate the membranes one from the others, or all others. The phase space, and of course this is not dissimilar to the membranes and information on each membrane, and as exactly copying the symmetry of information occurring on the surfaces, this phase space exactly copies the distance, or the area of space, or the line measurement, or the distance between the real object and mirrors B or C. So in the virtual recursion, the mirror dimensions is copied. The mirror dimensions representing the dark matter plane surface that is potentially reflective. The phase space also communicates the information that's found on that mirror on each stage of recursion. And as well, the phase space copies the distance between the real object and the mirror surface. So really, in this